The Next Generation Space Telescope has since been deployed out into space, and its recent findings have been amazing, with new technology allowing astronomers to peer deep into space like never before. The James Webb Space Telescope will answer so many core questions about space. From a peek into the first galaxies to exoplanets that may support life, this infrared observatory out in orbit is humanity's latest tool seeking understanding about the unknown universe. Keep watching until the end of this video as we take a peek through this unidentified object in the universe. All of these scientific findings will blow your mind. Welcome to Space Infinity. The James Webb Space Telescope. Humanity has always peered through the skies, wondering about the great beyond, the vastness of space. The heavenly bodies were once worshipped as great gods and deities, with ancient civilizations that studied ancient astronomy, able to gain an understanding of the motion of the stars, the sun, and other planets. Our ancestors peered through the night sky, plotting the universe as they saw it. Our interest in astronomy is dated and documented through cave paintings and historic glyphs on rock dated thousands of years into early civilization. From looking up into the stars and gazing in wonderment, man has invented tools that magnify and clarify that which is yet unseen. And from telescopes that gave perspective to modern technologically driven structures that are currently out in space, providing data and discoveries unlike never before. These tools now allow us to gain more understanding about that which we wonder about the universe. One of the most powerful and most recent tools humanity has in its array is the James Webb Space Telescope. Named after a former NASA administrator, the James Webb Telescope is an infrared observatory considered as a next-generation space telescope. It is currently orbiting around the Sun at about 1 million miles from Earth, with a mission of finding the first galaxies that formed in the early universe and to witness stars forming planetary systems. The jwst is the largest optical telescope out in space, with high resolution and sensitivity that allow it to view objects unseen by its predecessor, the Hubble Space Telescope. Launched on Christmas Day 2021, it's now embarked on its 10-year mission in space. The jwst has a primary mirror made of 18 hexagonal mirror segments made from gold-plated beryllium, able to observe low-frequency ranges and longer wavelength coverage, with greatly improved sensitivity so that even the faintest light may still be captured. This will enable investigations across many fields of astronomy and cosmology with better data. It's been designed to answer many of the core questions that have animated astronomers over the past half-century. This space telescope will rewrite cosmic history and is well worth the $10 billion that it cost. It is the most ambitious engineering initiatives that can greatly push forward our understanding of the universe. The Webb has the capability of looking out into space, light years into the past, billions of light years, to study every phase in the history of our universe. From the first luminous glows after the Big Bang, peeking through young galaxies to witness the formation of solar systems having the capability of supporting life on Terra-like planets, to the evolution of our very own solar system. It aims to build on the discoveries made from past efforts to find more answers. And at 1 million miles from Earth, it has a wide view of the dark cosmos, while also keeping the telescope's optics and scientific instruments cold enough to function most optimally. This effort is a collaboration of different space agencies, the Canadian Space Agency, the European Agency, with NASA of the US leading its design and development. Webb Discoveries. Since the James Webb Space Telescope was deployed at the end of 2021, it unfurled its primary mirror weeks later and started to transmit valuable data back to Earth. On July 11, 2022, US President Joe Biden previewed to the public the very first full-color image from the Webb, the deepest and sharpest infrared image of the distant universe so far. It's called Webb's First Deep Field, with the image showing galaxy cluster SMACS 0723, a cluster teeming with thousands of galaxies, including some of the faintest objects ever observed in infrared. This composite image was made from images at different wavelengths, delivered from space in only 12.5 hours. The jwst is achieving depths at infrared wavelengths beyond the Hubble Space Telescope's deepest fields, while also taking away the weeks it took for the data to arrive. The overall image is approximately the size of a grain of sand held at arm's length when looking up into the sky, as we are peeking into just one small galaxy cluster and find more of the most distant galaxies ever detected. This discovery only scratches the surface of Webb's capabilities in studying deep fields and tracing galaxies back to the beginning of cosmic time. More of Webb's fascinating discoveries were released as images featured some of the most compelling views of space. Webb was able to provide a detailed observation of a hot, puffy planet just outside our solar system called WASP 96b. This planet showed clear signs of water, with evidence of haze and clouds within it spotted by Webb, while previous studies were unable to detect the presence of H2O. Webb will seek out water in the atmospheres of exoplanets in hundreds of other systems to understand what other planetary atmospheres are made of. The powerful Space Telescope was able to observe the Southern Ring Nebula, a planetary nebula that is an expanding cloud of gas surrounding a dying star 2,000 light-years away. Webb's infrared was also able to bring a second dying star into full view for the first time. This allows scientists to track and explore the expelling shells of dust and gas of aging stars, which may one day become a new star or planet. Webb also provided a remarkable capture of the cosmic glyphs in the Carina Nebula, which provides a glimpse of the earliest phases of star formation. Webb focuses on newly forming stars to study the gas and dust that made them. Webb can also see in unprecedented detail how interacting galaxies are triggering star formation in each other, expunging gas in these galaxies in the process. This was seen on Stephan's Quintet, located in the constellation Pegasus, piercing through the shroud of dust surrounding the center of one galaxy. The center of this galaxy reveals the massive ferocity of its supermassive black hole. Scientists are now using the Webb to study this further. NASA's newest space telescope has the capability to find bright early galaxies that until now were hidden from view. Recent discoveries. Among Webb's latest discoveries is an image from the James Webb Space Telescope revealing a remarkable cosmic sight. At least 17 concentric dust rings emanating from a pair of stars. The duo of stars, collectively known as Wolf-Rayet 140, is located over 5,000 light-years from Earth. It is an O-type star born with at least 25 times more mass than our Sun, and is likely nearing the end of its life, when it will collapse and form a black hole. The star's orbits bring them together about once every 8 years, with dust marking the passage of their relative time. The Webb has captured the rings which were created when the two stars came close together and their stellar winds, or stream of gas, blow into space, compressing the gas and forming dust. This illustrates dust production of over a century within this system, while further demonstrating Webb's capabilities. Prior studies using ground-based telescopes only revealed 2 dust rings, while now at least 17 can be observed. As a powerful scientific tool, Webb's capacity to provide new discoveries is truly exciting. Its scientific instruments detect infrared light, a range of wavelengths invisible to the human eye. The new data provides the best evidence yet that Wolf-Rayet stars produce carbon-rich dust molecules, with the dust able to survive the most hostile environments between stars, going on to supply material for future stars and planets. It is estimated that a few thousand Wolf-Rayet stars exist in our galaxy, with only about 600 having been found to date. Another recent announcement was made on November 17th by an international team from the Harvard-Smithsonian Center for Astrophysics. Saw 2 exceptionally bright galaxies said to have been formed 350 and 450 million years after the Big Bang. Researchers have been uncovering galaxies even closer to the creation of the universe 13.8 billion years ago, with these candidates awaiting verification, indicating a very radical and dynamic time in astronomy, all due to this new and much more powerful tool. If findings are verified and even more early galaxies are mapped, this will prove highly successful in pushing the cosmic frontier all the way to the brink